Hi, welcome back to my channel pibyme Maths. This is WMA12. Here we are solving Pure Math 2 January-February 2022 paper. In part 1, we have already finished question number 1 to 5. Let's look at question number 6. So this is from coordinate geometry. You have a circle and the point PQR lie on the circle. Show that angle PQR is 90 degree. Okay, we connect this PQ. Okay, we have a triangle now. They want us to show that this angle is 90 degree. This angle is 90 degree. We have learned the circle theorem. Angle in a semicircle is 90 degree. So definitely this is a semicircle. That means RP is a diameter, right? Okay. So how do we prove that the angle is 90 degree? There are several ways you can prove it. The easiest way is by taking the slope. If you take this slope and if you take this slope of this line, they both are perpendicular. We know slope of one line should be a negative reciprocal of another line if they are perpendicular, or in other words, when you multiply the slopes, you should get negative one. That's a condition for the two lines to be perpendicular. So that's a method we are going to use here. So let's find the slope of so we can write slope of PQ times slope of RQ should be equal to minus 1. Let's find PQ. Y2 minus of minus 30. Sorry, Y2 is 14 minus of minus 30 divided by, we can find PQ first. Y2 minus Y1 so plus 30 divided by X2 minus X1. So that's basically 44 over 23 minus 15 is 8 is 11 over. Find the slope of RQ now. Minus 26 plus 30 Y2 minus Y1 over X2 minus X1. That's minus 26 plus 30 is 4 over minus 7 minus 15. It's minus 2 over 11. Look at the slopes. One is a negative reciprocal of another one, right? So therefore they are definitely perpendicular, correct? So how do we write the conclusion? You need to write MPQ times MRQ is equal to minus 1. When you multiply both, you will get minus 1. Therefore, angle PQR is equal to 90 degree. That's one method. You can use Pythagoras theorem also. You can prove a square plus b square is equal to c square by using the distance formula. That's another method. Since it's a 2-mark question, the slope will be the easiest, faster method actually. Let's move on to part B. Hence or otherwise, find the center of C. The center is basically the midpoint of RP. So the center is midpoint of RP is x1 plus x2 by 2 minus 7 plus 23 over 2 y1 plus y2 minus 26 plus 14 minus 26 plus 14 over 2. So that's going to be 16 over 2 is 8 minus 8 over 2 is minus 12 over 2 is minus 6. Now the radius is, we know the center 8 comma minus 6. 8 comma minus 6. You can find the distance between any of these pair of points. That would be the center. So I'm going to take R of minus 7 comma minus 26. And then the center 8 comma minus 6. So the radius is square root of x2 minus x1 the whole square plus y2 minus y1, so minus of minus 26 whole square. That's basically square root of 15 square plus 20 square is 25. That's all. Part C. Given that point S lies on C such that the distance QS is greatest, okay, find the equation of the tangent at S, giving you answer in this form. Part C now. Given the point S lies on C such that QS is greatest, what do they mean by that? Okay, you need to take another point on that lies on this circle S. It can be anywhere. But the distance from Q to the point should be greatest. So definitely QS should be the diameter in order for the distance to be greatest. So the point cannot be anywhere else. The point should be here because it's a diameter for this to be the greatest. So S will be here. Okay. Now we are going to find the coordinates of S first using vector translation method. Okay. I'm going to draw the line here. Q is here. 15 comma minus 30. The midpoint is here. 8 comma minus 6. What would be this point? 8 plus 7 is 15, right? So to find the other point, you need to put 8 minus, or you can use the midpoint formula also. Take it as AB or XY. A plus 15 over 2 is 8. So A is 16 minus 15 is 1. B minus 30 over 2 is minus 6. So B is minus 12 plus 30, 18. That's one way. Or just use the vector translation. This is plus 7. So this point will be minus 7. Minus 6 minus 24. So this will be plus 24. You will get the point. So anyway, the point S is 1 comma 18. Now we need to find the equation of the tangent at this point S. This equation of the tangent. We know the point 1 comma 18. We need the slope of the tangent, slope of this line. So we are going to find the slope of the radius first, because these two are perpendicular, right? Radius and the tangent. So slope of the radius is y2 minus y1 over x2 minus x1, which is minus 7 minus 24 over 7. Therefore, the slope of the normal, not normal actually, tangent, that's a perpendicular line. You need to take the negative reciprocal, 7 over 24. So we have a slope, we have a point, we can find the equation already. So the equation is y minus y1, this is x1, y1, this point, is slope times x minus x1. They want you to write the equation in the form of ax plus by plus c is 0. So get rid of the fraction, multiply through it by 24 first. 24y minus 18 times 24. 432 is 7x minus 7. So move everything to this side. 7x minus 24y. Minus 7 plus 432 is 425 is equal to 0. That's all. Question number 7. Solve from minus 90 to 90 this equation. It's a 4-mark question. Divide throughout by cos. So you will get 3 sine over cos is tan 2x minus 15 is equal to 1. So tan 2x minus 15 is equal to 1 over 3. So first find the principal value, tan inverse of 1 over 3 in degree mode. Take the degree mode, tan inverse of 1 over 3 is 18.434. 18, do not round the figure, we will round the figure at the end. So I'm going to store the value as usual as A. Now use the ASTC diagram, the CAS diagram. The limit given is minus 90 to 90, but since you have 2x here, we should have multiplied the limits by 2. So the limit is 0 to 180 and 0 to minus 180. So you have to check in which quadrant tan is positive. Tan is positive here and here. So it's theta. This is on the negative limit, so minus pi plus theta. So 2x minus 15 is, theta is a principal value, 18.434, comma, minus pi plus 18.434. So we need to get these two values, but we need to use the degree minus 180, not pi. This is also minus 180. So make x as a subject now. So we store the value as a plus 15 divided by 2. 16.7. They want the answer to one decimal place. So 16.7 degree and then minus 180 plus 8 plus 15 divided by 2 is 73 point minus 73.3 degree. We got two solutions already. So here also it should be minus 180. Okay, let's move on to next question. They want you to solve another trigonometric equation. Okay, we need to convert everything into a single trigonometric function. So I'm going to replace sine square by 1 minus cos square using the identity cos square plus sine square is 1. Put the 3 also this side. Open the bracket, minus 4 cos square plus 8 cos theta. 4 minus 3 is 0. Multiply through it by negative 1. 4 cos square minus 8 cos theta minus 1 is 0. And then solve this quadratic. 4 minus 8 minus 1. Okay, we get a third form. So write this step. Cos theta is minus b plus or minus square root of b square minus 4ac over 2a, and then write the solution. 2 plus or minus cos theta is equal to 2 plus or minus square root of 5 over 2. We are going to solve this equation. There are two equations. We are going to solve them in this limit. Cos theta is 2 plus root 5 over 2. Cos theta is 2 minus root 5 over 2. The limit is 0 is less than theta is less than 2 pi. Let's find the principal value, cos inverse of this. They have used the radian mode, so change it to radian mode. Cos inverse of 2 plus root 5 over 2. Why I'm getting error? Okay, maybe I need to close the bracket. Okay, because what's happening here, 2 plus, if you find the value of 2 plus root 5 over 2, the value is more than 2. The range of cos is minus 1 to 1, right? So here you need to write no solution. For the next one, what's the value of 2 minus root 5? That's a negative number, right? So when you find the principal value, you need to take the positive number. That's a method I teach actually. So times minus 1. So cos inverse of the answer is 1.452 dot dot dot. That's not the final solution. Use ASTC diagram. Check the limit covers all the 4 quadrants. Check in which quadrant cos theta is negative. This and this. Pi minus theta and pi plus theta. Theta is this. I'm going to store it as A. So pi minus theta. They want the answer to 3 significant figure. So theta is equal to 1.69 and then pi plus theta 4.59 radians. That's all. Question number 8. This is from sequences and series. A metal post is repeatedly hit in order to drive it into the ground. Given that on the first hit, the post is driven 100 mm into the ground. On the second hit, additional 98. So the total will be 198. On the third hit, additional 96. So 198 plus 96 will be the total depth, right? Etc. etc. This forms an arithmetic sequence. Show that the post is driven an additional 62 with the 20th hit. Basically, they want you to find the 20th term. The formula is A plus 20 minus 1D. A is the first term. 20 minus 1. The common difference is A2 minus A1 is minus 2. That's minus 38. 100 minus 38 is 62 mm is the answer. It's already given here. They just want us to prove. It's one more question. Part B. Find the total distance. So we have 100 plus 98 plus 96 plus etc. etc. We know the 20th term also. They want you to find the sum of this. So sum of 20 terms is equal to n over 2 times first term plus last term. 162 times 10 1620 mm will be the total distance the post has been driven into the ground. Part C. Given that subsequent heat after the 20th heat, the additional distance post travels from a geometric sequence now. So from the first heat, 96, 98, all the way to 20th heat, right? This is first, second, third. Okay, from 21st after, given that for each subsequent heat after 20th, the additional distances forms a geometric series. So we know the 21st one, but 22nd heat, the post has driven additional 60. It forms a geometric series now. So if you take this as first term, this is second term, this is AR square. AR square is 60. We know A is 62, bring it to the other side. R square is 60 over A. And then find R to 3 decimal places. Square root of 60 over 60. 0.9837 dot dot dot. They want the answer to 3 decimal place. Therefore, R is 0.984. And then I'm going to store this value as B. Okay, next part now. A total of n hits, the post will have driven more than 3 meters into the ground. Okay, in the first hit, it's 100. In the second hit, it's 96. Third hit, 98. All the way to 20th hit, it was 62. We don't know 21st one. And then 22nd hit, it's 60. Dot dot dot. Total of n hits. The total, if you add everything, it will be 3 meters. 3 meters. So meter, you change it to millimeter. It's going to be 3000. The sum is 3000. So what's given here? Sn is equal to 3000. More than 3000, sorry. More than 3000. We need to find the value of n, capital N. Okay. We know from 1 to 20, the sum is, we calculated here. It's 1620, right? So 1620 plus. Now the sum from 21st term to nth term. We don't know the 21st term, right? But we know the common ratio. So we can write it as 62R, right? That's the first term, correct? The R is the common ratio. So this is basically 62R plus 62R square plus etc. n terms. This sum is greater than 3000, right? Here when you find the common ratio, it's the same. Second term divided by the first term, you're going to get the R. So it's, you bring this to the other side, 3000 minus this. So here A times 1 minus R to the power n divided by, okay, this n is the total number of terms actually, not from 21 to this. So this n, capital N, is basically, if I take this as small n, 20 terms plus n, that should be the capital N. Okay, so we are going to take it as small n terms divided by 1 minus R is greater than 3000 minus this, which is 1380. And then we replace R by the value of R. So 62 times the value of R is 0.983 dot 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 times 1 minus 0.983 dot 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 to the power n divided by 1 minus 0.983 dot 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 is greater than 1380. Now we need to make n as a subject. Okay, first of all, we can bring this to the multiplication numerator and this to the denominator. Okay. So 1380, I stored the value as B, I guess. Yeah. So 1380 times 1 minus B. Get the value divided by this. Divided by 62 times R again. So 1 minus 0.983 dot 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 to the power n is greater than this value 0.036 dot dot dot. Okay, and then bring this term here, this term here. You're gonna get 0.983 dot 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 to the power n is less than 1 minus this value. Okay, I think I messed it up here. 1380 times 1 minus b, get this value, divided by 62 times b. Okay, we got this value minus 1 minus actually 0.632 dot dot. It has to be positive. So I'm gonna store this value c. Take logarithm both sides. So you can put n in front. N log 0.983 dot 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 is less than log 0.632 dot dot. You need to divide by this. Since it's an inequality, you need to check whether it's a positive number or negative number. So log b is a negative number. So when you divide, you need to flip the sign. N is greater than log 0.632 dot 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 divided by log 0.93 dot dot dot. I have stored both the values. Log c divided by log b. I got 27. So n is greater than 27.98. So take the next integer, n is equal to 28. And we know capital N is 20 plus small n, right? So you need to write, therefore, capital N is 20 plus 28 is equal to 48. That's the answer. Question number 9. We have a diagram given, a curve, straight line, two shaded regions. Let's read the question. Figure 2 shows the curve with the equation y is equal to x minus x square. So this is C is y is equal to x minus x square. And then the line is y is equal to mx, but m is between 0 to 1. So equation of the line is y is equal to mx. The line and the curve intersect at origin and P. As you can see here, they intersect at origin and P. Find in terms of m the coordinates of P. Just solve these two equations. Mx is equal to x minus x square. Move everything one side. X square plus mx minus x is 0. Take x as a common factor. X plus m minus 1 is 0. So x is 0. That's a origin. And x is 1 minus m. And when you sub in, we need the coordinates. When you sub in here, when you sub in 0, you will get 0. That's the origin. When you sub in 1 minus m, y is m times 1 minus m. Therefore, the point P will be 1 minus m, comma, m times 1 minus m. These are all the coordinates of P. It's a 2-mark question. Part B. The region R1 shown shaded in figure is bounded by the curve and L. They're talking about R1. Yep. It's bounded by the curve and L. Show that the area is this. How do we find this area? When you find the area of the curve, area below the curve from 0 to P, you will get the whole area till here. When you integrate the curve from 0 to P. And when you integrate the straight line, you will get the area below the straight line. Right? Subtract them, you will get R1. So that's what we are going to do. So the curve on top, the function on top is a curve. The function at the bottom is a straight line. So what we are going to do, R1 is equal to integral 0 to x coordinate of P, the curve minus the straight line dx. So that's going to be x square over 2 minus x cube over 3 minus m x square over 2, 0 to 1 minus m. Oh, it's a 5-mark question because you need to sub in the x coordinate at the upper limit in the place of x and then simplify it to this. When you sub in the lower coordinate, lower limit, everything will be 0. So just sub in the upper limit. 1 minus m whole square by 2, 1 minus m whole cube by 2, m times 1 minus m whole square by 2. Don't open the bracket and make it complicated. You need to keep it this way and see how you can get this answer. Okay, we need to get this answer from this step. So we can take out the common factor 1 minus m whole square over 2. The first term has 1. The second term has 1 minus m. The third term has minus m. The second term was 3, right? Not 2, it was 3. So, sorry, this term was 3 actually, this denominator. So, we can multiply this by 3, this by 2, this by 3, we'll get a common denominator 6. So, we get a common denominator 6. We need 6, right? So, we'll keep it as it is. The numerator, you have 3 times 1 minus m whole square minus 2 times 1 minus m whole cube minus 3m times 1 minus m whole square. So from the numerator, I'm going to take out the common factors. 1 minus m whole square as a common factor. In the first term, I'm left with 3. In the second term, 2 times 1 minus m. In the third term, minus 3m over 6. Simplify it. 1 minus m whole square times 3 minus 2 plus 2m minus 3m over 6, which is 1 minus m whole square. 3 minus 2 is 1. 2m minus 3m is minus m. We got the answer already. Whole cube over 6. Part C. The region R2 is also shown shaded in figure bounded by the curve x-axis and L. R2. Yes, R2 is here. It's bounded by the line, x-axis and the curve. Okay. Now, given that the area R1 is equal to R2, find the value of M. We know the value of R1 already from the previous part, 1 minus m whole cube over 6. Now we need to find the area of R2 and equate it to this. Let's look at the figure. How do we find the R2? When you integrate the line from 0 to this point, x coordinate of this point, you will get this area, right? And then if you integrate the curve C from 1 minus m to this point, the x coordinate of this point, you will get this area. And you need to add them. Okay. So first we integrate the straight line from 0 to this. And then what would be the x coordinate here when you replace x by 0 in this curve? So y is equal to x minus x square. When you replace y by 0 to find the x coordinate, x minus x square is 0. X times 1 minus x is 0. That means it has 2 x-intercept. X is 0 and 1. Origin x is 0 and this point is 1. Okay. So we are going to integrate the curve, integrate the straight line first 0 to 1 minus m mx dx plus integrate the curve from 1 minus m to 1 x minus x square dx. This is what R2 is. And equate this to get the answer, equate this to R1. So when you integrate mx square over 2, 0 to 1 minus m, x square over 2 minus x cube over 3, 1 minus m to 1. When you sub in the upper limit, 1 minus m whole square over 2, lower limit is 0 leaving. Sub in the upper limit, 1 over 2 minus 1 over 3. Lower limit, 1 minus m whole square over 2, 1 minus m whole cube over 3. So I'm going to take this whole thing, equate it to this and make m as a subject now. So m times 1 minus m whole square over 2. When you simplify this, 3 minus 2 divided by 6 is 1 over 6. And then open the bracket, minus 1 minus m whole square over 2 plus 1 minus m whole cube over 3 is equal to R1. There are a lot of working, but I'm not sure why the question has only 3 marks. They want you to find the value of m, just a 3-mark question. Okay. I'm going to divide throughout by 1 minus divide throughout by 1 minus m whole square. So in the first term, m minus 1 minus m whole square will be gone, m over 2. Okay, there is this here, 1 over 6 here, right? There is 1 over 6 first. We can get rid of this first. So we got this equation. We need to solve it, find the value of m. But the thing is, I'm not sure why the Pearson has given only 3 marks for this question. You see, even from here, solving this takes few steps actually. So to simplify it, I'm going to take 1 minus m is equal to x or p, let's say. I'll take it as x. So x is basically 1 minus m. I'm going to replace, m is 1 minus x. So I'm going to replace m by 1 minus x times x square over 2 plus 1 over 6. Minus x square over 2 plus x cube over 3 minus, put this also this side, is 0, right? Okay, open the bracket here, you'll get x square over 2 minus x cube over 2. Simplify this 2. You multiply by 2, you'll get the same denominator. 2x cube minus x cube is just x cube over 6. Okay, and you can cancel these two, and when you simplify these two, they are like terms, so you're gonna get minus 1 over 2 plus 1 over 6. It's minus 1 over 3, so minus x cube over 3 plus 1 over 6 is 0. So x cube over 3 is 1 over 6. So x cube is equal to 1 over 2. X is cube root of 1 over 2. Replace x by this. 1 minus m is cube root of 1 over 2. Make m as a subject. Therefore, m is equal to 1 minus cube root of 1 over 2. All this working for just for 3 marks. I don't see any other shorter method. If you find any other shorter method, please leave it in the comment, please. Okay, so that's the value of m. That's all. Let's move on to question number 10 now. 10i, prove by counter example that the statement if p is a prime, then 2p is also a prime is not true. Okay, let's take a prime number 2. So 2p plus 1 is also a prime. Take another prime number. You can do mental math. You can use your calculator, get the number, just show the particular number. You don't need to write all this. 2 times 3 plus 1 is also a 7. We should get a number which is not a prime. So when I take 5, 2 times 5 plus 1, 11. If I take, okay, when I take 7, 2 times 7, 14 plus 1, 15. Not a prime. Therefore, write the conclusion. The statement is not true. You don't need to show all this. If you can find the number, just show this particular work. Double I now. Use proof by exhaustion to prove that if n is an integer, then this is always even. Okay. Usually in proof by exhaustion, we will sub in all the cases, right? But is an integer, it says there are plenty of infinite integers. So we are going to divide them into even integer and odd integer. And let's calculate this. 5n square plus n plus 12 is 5n square plus n plus 12, which is 20k square. So you take 2 as a common factor out. 10k square plus k plus 6 is even, right? Here 5n square plus n plus 12 is 5n square plus n plus 12. Expand the bracket. 4k square plus 4k plus 1, 2k plus 1 plus 12. That's 20k square plus 20k plus 2k, 22k. 5 plus 1, 6 plus 1, 18. That's 2 times 10k square plus 11k plus 9 is also even. And then write the conclusion. Therefore, for all integer n is equal to, if such as, right, if n is an integer, then this is always even. You need to write the conclusion at the end.